Hello guys, today I'm going to prove the product rule. This is the part 3 of proving famous limits and derivatives. Okay, let's just get to the point. I don't want to waste any time. So we'll just use the first principle. I don't know, I'm printing bracket up. Let's just leave it. Okay, so I'm going to add and subtract a constant which is f. I'm not a constant. So add and subtract f plus h g of x. I'll add and subtract this. You will get to know why. So it will be limit as h tends to 0 of f of x plus h g of x minus f of x plus h g of x plus f of x plus h g of x minus f of x g of x all over h. So we'll take the common factors. F of x plus h is common, so it will be, my bad, this is plus g of x plus h, my bad. Minus g of x over h. Same. Okay, I'll split the fraction and take common, so it will g of x is common. Okay, now I'm going to split the limits, this and this. I'll split the limits. Okay, now, okay, first I'll split the limit between this and this. And okay, about this, okay, we can take this outside because there is no h in g of x. So g of x is a constant with respect to h. Okay, now we are going to do something. First, see this one, observe this. As h tends to 0, this is just f of x. This is the definition of derivative of g of x. This is just first principle. This is the g of x, and this is the definition of derivative of f of x. And boom, we proved the product rule. Now I'm going to prove the quotient rule. Okay, so let's prove the quotient rule now. Same thing, apply the use the first principle. Plus h we'll take LCM here. We took LCM. Now what I'll do is bring this down, so it will be limit as h to 0 of f of x plus h g of x minus f of x g of x plus h. Okay, coming back to the point, it will be, this will be over h into 1 over g of x plus h g of x. Now I'm going to split the limit, so it will be limit as h tends to 0 of g of x plus h over h times limit of h tends to 0 of 1 over g of x plus h g of x. Okay, first, as h approaches 0, this will be 1 over g of x times g of x, which is 1 over g of x squared. So we'll just do that right now. Limit as h tends to 0 of f of x plus h g of x minus f of x g of x plus h over h. We know that this is 1 over g of x squared, which I just explained. This limit is separate, by the way. Okay, now we are going to again add and subtract f of x and g of x. We'll add and subtract this, so it will be limit as h tends to 0. Add and subtract this in the numerator. Minus f of x g of x plus minus f of x g of x plus h all over h. Same thing, we're going to take common. We'll take g of x common. It will be f of x plus h minus f of x over h plus limit as h tends to 0 of f of x g of x minus g of x plus h over h. Now same thing here, I explained in the product rule that this is a constant with respect to h, so we can just take this common. Oh yeah, okay, by the way, I forgot to write this, so I'll add this later. Let's call it hash. I forgot to add this, my bad. I'll just write it hash and I'll add it later. So we'll take g of x times this limit of h tends to 0 of f of x plus h minus f of x over h. Same thing we'll do here, but here I'm going to take negative f of x common. The reason why is I'll explain you. So this will be minus of g of x plus g of x plus h. Wait, yeah, my bad, I forgot to write f of x over here. Okay, so yeah, g of x, and this will be plus g of x plus h over h. Okay, the reason we took the negative is because, okay, first so this will be g of x times, this is obviously the definition of derivative of f of x, it will be f dash x. Okay, obviously this is a constant with respect to h, so we can take, this will be minus f of x because minus plus is minus. Limit as h tends to 0, we can rewrite this as g of x plus h minus g of x over h. Well, you times hash. The hash is obviously this. I'm going to add it later. So this is f dash x, by the way. So this equals g of x times derivative of f of x minus f of x times the derivative of this. I mean, my bad. This is the definition of derivative of g of x. So it will be g dash x and times hash. What was hash? Hash was this. So we can write g of x times f dash x minus f of x times g dash x all over g of x the whole square. And guys, here we proved it. I'm sorry if you didn't see the hash over here, I just wrote over here. That's my mistake. Thank you for seeing the video. Next video I'll prove the chain rule. Bye.